Every morning across Canada, engines are destroying themselves from the inside, and the people who service them knew exactly how to prevent it. Not suspected, knew. The data has existed for decades. The solution costs less than a tank of gas per year. And the dealer who did your last oil change made a different choice. My name is Abraham, and this is Drivin' Broke. Your engine ran dry this morning. Not empty, dry. For somewhere between 8 and 14 seconds after you started it. Every camshaft lobe, every rocker arm, every bearing surface in your upper valve train ran at 800 revolutions per minute with no oil film between them. The oil was in the pan. It was not moving through the galleries. It was not reaching the components that needed it most. And in Edmonton, Calgary, Winnipeg, and Saskatoon, where that vehicle sat outside overnight at -25 or -30, that oil was not behaving like oil at all. It was behaving like cold syrup forced through passages measured in millimeters. 8 to 14 seconds does not sound like much. Multiply it by every cold morning of every Canadian winter you have owned that vehicle and then tell me it does not sound like much. Study after study published through SAE International confirms that somewhere between 75 and 80% of total engine wear over a vehicle's lifetime happens in the first 60 to 90 seconds of a cold start before oil has fully circulated. That is not a fringe number. That is the mechanical reality of every engine ever built. The engineers who designed your engine knew this number. The legal team that wrote your warranty knew this number. The service advisor who filled your last oil change knew this number. What each of them did with that knowledge is the reason you are watching this video. That is the pattern. And it starts with the number on your oil cap. The number before the W is the only number that matters on a Canadian winter morning. A 10W, 30 at -25 does not flow like oil. It moves like cold syrup through galleries measured in millimeters. And the upper valve train, your camshaft lobes, your rocker arms, your lifters receives no pressurized lubrication for 8 to 14 seconds after startup. Metal on metal. Every morning, all winter. I pulled apart an engine 2 years ago that had been run on 10W, 30 conventional through 4 Edmonton winters by a driver who followed every interval on the sticker and never missed a single service. The cam lobes looked like someone had taken a grinding wheel to them. Smooth where they should have had surface, flat where they should have had a lobe profile. The driver had no warning, no noise, no light. Just a repair estimate for $7,400 and a service advisor who suggested the damage was probably just wear. It was not just wear, it was predictable, preventable, and profitable for everyone except the person who owned the vehicle. A 0W20 or 0W30 full synthetic reaches critical upper valve train components in roughly 2 to 3 seconds at -25 compared to 8 to 14 seconds for a 10W30. That is not marketing language. That is SAE 300 cold cranking viscosity data. The 0W rating means the oil has been tested and certified to flow at -35 before the engine fires. That gap, 3 seconds versus 14 seconds of metal-on-metal contact at 800 revolutions per minute, is the gap between an engine that is reliable at 200,000 kilometers and one that is heading toward $4,000 to $12,000 in upper valve train or bearing damage across 3 or 4 Canadian winters. The cost of switching to a 0W, grade full synthetic, is $12 to $18 more per oil change. The math does not need my help. Most dealerships in Canada operate on bulk oil supply contracts. One grade, purchased in volume, dispensed to every vehicle that comes through the service bay regardless of that vehicle's cold temperature exposure, parking situation, or commute pattern. The grade is selected for cost and compatibility with the broadest possible range of vehicles, not for outdoor overnight parking in Winnipeg in January. The service advisor who filled your last oil change did not ask whether you park in a heated garage, did not ask how far you drive to work, did not ask what temperature your vehicle sat at last night. They pulled from the bulk tank and moved on. That is not incompetence. That is a supply contract making decisions that should belong to you. And the oil in that bulk tank may have carried a certification symbol that made it look like the right choice. Understand what that symbol actually is. One was formulated to protect the oil company's margin and pass a minimum test. The other was formulated to protect your engine. Both carry the same API SP certification symbol on the label. That symbol is a floor. It is the minimum threshold required to print those letters on a bottle and sell it legally in Canada. The gap between meeting that floor and actually protecting an engine during a cold start at -30 is measurable, and it is significant. The most important anti-wear compound in engine oil is ZDDP, zinc dialkyl dithiophosphate. It forms a protective film on metal surfaces during the high-pressure, low lubrication conditions of a cold start. Economy conventional oils carry ZDDP concentrations adequate for mild temperatures and highway driving. Premium full synthetic formulations from manufacturers who publish their technical specifications carry concentrations that are measurably higher. In some cases, 3 times higher. That difference is the difference between a cam lobe that survives a Thunder Bay winter and one that does not. The NOAC volatility rating tells you how much of the oil burns off during operation. A high NOAC number means more oil consumption, thinner film strength, and faster additive depletion. This matters most during the short, cold trip driving pattern that defines winter commuting in Saskatoon, Sudbury, and Prince George. A premium full synthetic costs $9 to $14 per liter. Economy conventional costs $5 to $7. Premature camshaft lobe wear from inadequate cold start protection costs $2,800 to $5,500 on the vehicles that present it most commonly. That math also does not need my help, but here is what does need explaining. Because the cold start is only part of what is happening to your engine this winter. The second part starts after the engine is running, and it is invisible until it is not. Picture a driver in Montreal, February, -22 overnight, 6-kilometer commute to work, 6 kilometers back. Done it for 3 winters without thinking about it. The engine warms up. The temperature gauge moves to normal. Everything looks fine. What that driver cannot see is what is happening inside the crankcase during those 12 kilometers. Full operating temperature, the temperature required to boil off the moisture and combustion blow-by that enters the crankcase every time that engine runs, sits at approximately 93 degrees Celsius at the oil. A 6-kilometer commute at -22 starting from a cold soak does not get there. The coolant temperature stabilizes. The oil temperature does not follow. The moisture from combustion blow-by has nowhere to go. It stays in the oil. It accumulates. Every day, every week, all winter. Send that oil to a used oil analysis lab after 8,000 kilometers of that driving pattern and look at the moisture content, the acid number, and the iron particle count. The numbers describe an oil that stopped being a protective fluid somewhere around kilometer 4,000 and has been doing active damage since kilometer 6,000. The dashboard showed nothing. The dipstick showed full. The oil change sticker said the driver had 4,000 kilometers left. Let that sit for a moment. The interval printed in that manual was not calculated for this. The oil life monitor algorithm on that dashboard was not calibrated for a 6-kilometer daily commute at -22 inches Montreal with overnight outdoor parking. Those systems were calibrated for moderate temperatures, mixed driving, and enough highway time to stabilize oil temperature regularly. Extended intervals are also a commercial product. They are a selling feature on new vehicles. They reduce dealer service visits, which sounds like a consumer benefit until you understand that fewer visits means fewer inspections, fewer caught problems, and fewer opportunities for the kind of conversation that would require the dealer to admit the interval is wrong for your actual driving pattern in your actual climate. The interval was not extended because it is better for your engine. It was extended because it tests better in cost of ownership advertising. For a Canadian short-trip winter driver parking outside in Edmonton, Sudbury, or Prince George, the correct interval is 5,000 kilometers or 6 months, whichever arrives first. Not the sticker, not the monitor, the climate and the commute. Drop a comment right now. Tell me what oil you are running this winter, what province you park in, and what temperature your vehicle sat at last night. Edmonton, Winnipeg, Prince George, Whitehorse. I want to see how many Canadian drivers are running the wrong protection for their actual climate. Because what comes next is the part where the individual failures stop being individual. Every failure we have covered so far, wrong viscosity, inadequate additive package, moisture dilution from short cold commutes, an interval that was never designed for your driving pattern. None of them operate in isolation. They stack. And they stack on top of a fourth factor that is specific to Canadian roads and that accelerates every one of the failures above it. Road salt. Not as a surface problem, as a crankcase problem. Canadian winter road maintenance applies sodium chloride and calcium chloride at rates that saturate the road surface and wheel wells of every vehicle in Ontario, Alberta, Quebec, and across the Maritimes from October through April. Those chloride compounds enter the engine environment through the PCV system. That is your positive crankcase ventilation system. Its job is to manage blow-by pressure inside the crankcase. In cold operation, the PCV valve on many common Canadian market engines restricts or partially freezes. That changes the pressure balance in the crankcase. It increases the rate at which contaminated air moves through the oil. Chloride compounds accelerate oil oxidation. They attack the additive package. They reduce film strength. That gap is where the bearing dies. Applied to oil that is already cold thickened, moisture diluted, and running past its effective service interval, chloride-accelerated oxidation creates a bearing environment where the oil film separating metal surfaces is thin, degraded, and losing protective capacity faster than any single factor could cause alone. The PCV system is a sealed emissions component. It is not on any standard inspection checklist at a Canadian Tire oil change. Most dealerships do not inspect it unless it has visibly failed or triggered a code. It is degrading your oil's protective capacity right now, and nobody at the service counter has ever mentioned it because mentioning it does not generate a billable repair at the moment it matters. It only generates one after the bearing is gone. Some of you just got angry. Good. Because this is where the cost becomes real. A spun bearing does not announce itself early. There is no warning light for the early stages of bearing wear. There is no gradual noise that builds over weeks and gives you time to plan. The first symptom most drivers notice is a knock. A deep rhythmic knock from the lower end of the engine. By the time you hear that knock, the bearing is gone. The journal surface may be scored. The crankshaft may be damaged. You are not looking at a bearing replacement. You are looking at a short block. In a 2018 to 2023 Canadian market half-ton truck or three-row SUV, short block replacement runs $6,500 to $14,000, depending on the engine, the labor rate, and what secondary damage the failure caused before it stopped. That bill arrives with no warning and no coverage, because spun bearing failure from wear is classified as a maintenance failure, not a manufacturing defect. The powertrain warranty your dealer presented as peace of mind was written specifically to exclude it. The manufacturer's engineering team identified this failure mode in pre-production testing. The legal team reviewed the failure timeline, how many winters of wrong oil at wrong intervals it takes to produce this outcome, and wrote the warranty duration accordingly. The warranty was designed to expire before the engine does. That is not a coincidence of timing. That is actuarial analysis applied to your repair bill. Now here is where every failure in this video traces back to a single decision that was made before you ever sat in that driver's seat, before you signed the papers, before you drove it off the lot. The oil that was in that engine on day one was not chosen for you. Factory fill is selected for global production logistics, compatibility with assembly line tooling, and compliance with minimum certification standards across the broadest possible international market. A 2020 Ford F-150 with the 5.0-liter ships from the factory with a 5W20 specification and an oil life monitoring interval that can stretch to 16,000 kilometers under the right algorithm condition. A 2021 Honda CR-V ships with 0W20 full synthetic and an 8,000 kilometer interval. A GM half-ton with the 6.2-liter carries a 0W20 Dexos 1 Gen 3 requirement. Those specifications exist on a spectrum. Some of them are adequate for Canadian winter conditions. None of them were selected for a vehicle that will park outside in Saskatoon at -33, run 6-kilometer commutes for 5 months, and accumulate 14,000 kilometers per year almost entirely in the worst possible operating conditions for engine oil. The factory fill and the factory interval were both calculated for the globally distributed average vehicle owner. You are not the global average. You are parking outside in Whitehorse, and nobody who specified that oil has ever spent a January there. Here is the complete math. Switching to a 0W20 or 0W30 premium full synthetic and shortening your interval to 5,000 kilometers or 6 months in Canadian winter driving conditions costs roughly $220 to $380. More per year than economy conventional at a dealer-recommended extended interval. Over 5 years, that is $1,100 to $1,900 in additional maintenance spend. The upper valve train damage, bearing damage, and short block failure scenarios covered in this video cost $2,800 to $14,000 depending on the failure point and the engine. 5-year cost of correct maintenance, approximately $1,500 at the midpoint. 5-year cost of inaction, approximately $8,000 at the midpoint. That is a 5-to-1 return on a decision that requires one conversation at the service counter where you say the words 0W, full synthetic, and 5,000 kilometers and mean every one of them. The people who profit from you never having that conversation are not difficult to name. Oil companies that sell economy conventional on the strength of a certification floor set to accommodate their cost structure. Dealerships running bulk supply contracts optimize for margin per oil change, not engine protection per winter. Manufacturers whose warranty language was drafted around failure timelines their own engineering teams calculated in pre-production. Every one of those parties has a direct financial interest in you continuing to follow the sticker, trust the monitor, and assume the system was built to protect you. It was not built to protect you. It was built to extract value from you for as long as your engine holds, and then extract more when it stops holding. Subscribe. Because next week this channel goes inside the coolant system failure that is accelerating in Canadian market engines every spring thaw. It starts in October when the freeze-thaw cycling begins and does not present as a problem until a morning in May when the temperature gauge climbs past normal and keeps going. Every dealership in Ontario and Alberta is currently advising Canadian drivers to wait until their next scheduled service before addressing it. The engineers who design those cooling systems know exactly what 3 Canadian winters of freeze-thaw cycling and road salt do to the inhibitor package in conventional coolant. The warranty language around cooling system failure was written with that timeline in mind.